Good evening everyone. In the last class we studied about the electromagnetic spectrum and we see that what are the frequencies that we use in the advanced communication systems, that is gigahertz, terahertz and pentahertz. After that we study one important point. At very high frequencies we always give importance for the wavelength instead of frequency, and we see the reason for going for the higher frequencies, that is BUR, bandwidth utilization ratio. And after that we study about the simple block diagram of optical communication system, which consists of 3 blocks. Not only optical communication system, any communication system consists of 3 blocks. The first block is transmitter, second block is channeler medium and the third block is the receiver. So you observe clearly such that electrical to optical conversion with the help of light source and uses the intensity modulation by the transmitter in optical communication system. If you talk about the channel is dielectric in nature, which is manufactured by using 2 materials, one is glass, other one is plastic. So coming to the receiver always performs the inverse operation to the transmitter. On the other hand, you observe very clearly such that it performs optical to electrical conversion, and it with the help of light detectors or photo detectors providing the signal restoration. So this is what about the simple block diagram studied in yesterday's class, and I already explained to you about the elements of optical communication system and also some topics of review of optics also, and in that I will tell you some points like a brief, the components that use in the optical communication system as connector, temporary connection, splice, permanent connection, and if you talk about the third important one, it is said to be the coupler, which couples the power to multiple circuits, okay, not only to the one-to-one connection, one-to-many connections, okay. And coming to the last one, there is a fourth component which is called as the repeater. A repeater performs the function called as regeneration. So one of the most important thing that we can see for the long haul communication systems. So these things we studied in the yesterday's topic. So remaining things we study about the review of optics. In that we tell about the light nature, light have dual nature, and we also study about the next important thing, it's power. Power is nothing but an rate of change of your light energy, okay. So next important one is about the representation of power in terms of dBm and in terms of dB mu. So next one is nothing about the refractive index. So refractive index is nothing but an velocity of light propagating in vacuum to that of velocity of light propagating in any medium. So n is equal to c by v, n is equal to root of epsilon r, n is equal to lambda naught by lambda. Whenever the light changes from one medium to another medium, it changes its wavelength rather than the frequency. Frequency remains the same. For generation of light or for absorbing the light or emitting or absorbing the light, we can tell very clearly it uses the particle nature. When the light traveling from one point, from the source to the destination or from one point to the another point, it always obeys the wave nature. So, it has a dual nature, it is a dual nature we are having. So, these things we study in the yesterday's topic. Your optical power is also called as the radiant flux, denoted by phi. So, moreover things we see some of the important notations with respect to the power. So, dB plus dB is equal to dB. So, dBm minus dB is equal to dBm, and similarly if you talk about the dBm minus dBm is always equal to dB. So these things we study in the yesterday's topic. So after that we see about the Snell's law. Snell's law provides the angle of refraction. So n1 into sin theta 1 is equal to n2 into sin theta 2, where theta 1 is angle of incidence, theta 2 is angle of refraction. So next we see about the critical angle. Your theta 1 become theta c when theta 2 is equal to 90 degrees, which is called as the critical angle theta c. So next one is critical angle is the minimum angle we are having, and next one is called as TIR, total internal reflection. Light is reflecting into the same medium instead of taking the refraction, it is reflecting into the same medium. When angle of incidence is greater than theta c, then theta 1 is equal to theta 3, where theta 3 is called as angle of reflection. So these things we study in the yesterday's class. I just give a quick recap. to know about the concepts. The reason why I give a recap is nothing but an today's class is all about what we studied yesterday's class is required here. Okay, so guys, so welcome back to the session, and we are discussing about the today's topic in optical communication system, which is called as the acceptance angle. It is called as acceptance angle. By acceptance angle is denoted as theta in. Some books will also write as theta A also. I am not bothering about the notation, I am just very much concerned about the concept. So, how fiber is manufactured and how the light was passed and all those things I will explain to you. So, थोड़ा ध्यान से सुनो, इसके बाद कॉपी कर लेंगे, कोई दिक्कत नहीं है. बट द फर्स्ट 10 मिनट्स सो ज़्यादा इंपॉर्टेंट है, तुमको मालूम हो जाए को कॉन्सेप्ट में, सो द नेक्स्ट रिमेनिंग थिंग्स विल एंजॉय लाइक एनीथिंग. ओके, सो देखो भैया, या फर्स्ट पॉइंट we will tell about the fiber. If I will talk about a fiber structure, so I explain here about the fiber structure we are having. It is called as the fiber structure. So fiber is going to be having a core, which is represented by a very small core, and it is also having a clady. See, showing like this clady. This part is said to be called as core. The refractive index of core is N1, and the remaining part we are having is called as clad. Clad or cladding, what it may be, clad or cladding, both are same. It's not daddy, it's cladding. Okay, so core or clad is equal to N2, refractive index is N2, right. So after that you are going to be talking about the coating, and that coating is called as buffer coating. I am doing here, just observe it, that is called buffer coating. So buffer coating is nothing but you can find out in your, sometimes in your copper wire also, some white color powder has to be present when you cut out the jacket, outer jacket. Okay, outer jacket means it's a polythene, polypropylene or polythene type of cover we are having, plastic molded cover. Okay, so that's called as a buffer coating we are having, and after that we are having calver, which is also called as calver, buffer coating, and after we have a calver, and at last we are going to be having the outer jacket, and this is called outer jacket we are having. So these are the lines we are having the fiber. See, outer jacket, calver, buffer coating, clad, and core we are having. Okay, so clad as well as core is present. So what is this is called as outer jacket. I am writing here, it is called outer jacket, which we can find out in our fiber is this outer jacket only you can find. If you cut the fiber internally, you can find out like a small pieces of white color with the glass or with the plastic, they can be manufactured. You can see that is what said to be called as your fiber structure is present like this. Now just listen, I am showing the same thing, removing the calver, removing your outer jacket and the buffer coating. I am just showing the clad and core. So all of you please concentrate here, bhaiya. This is the core, which is manufactured by using the pure form of a glass. The refractive index of the glass we studied in the previous topics is nothing but an N1 is equal to, I hope everybody can remember the value. What is the refractive index of glass? The refractive index of glass N1 is, how much bhaiya? 1.5, very good. It is equal to 1.5 we are having. So that value is equal to 1.5 we are having. This is the core. So please understand the concept. It is manufactured with the pure form of a glass. There is no imperfections. It's a perfect fiber. Manufactured a perfect fiber we are having. There are no imperfections by a perfect fiber we are having. So this is the fiber we have. If you observe clearly here, the refractive index is N0, because along this fiber entire thing what we are having is called as air. It is called air. So N0, refractive index N0 is nothing but an air we are having. That N0 value is equal to air is present. So after that what you are trying to doing here is, we are talking about the light, how the light was going to be passing into a fiber, and this is called as the axis of the fiber. It is called as the axis of the fiber. Now see the first disadvantage of this model without having any cladding, I am explaining the disadvantages to you. Simple bhaiya, very simple. So assume that This is the fiber we are having. I hope you understand, it is a fiber we are having. So, it is having only pure form of the core we are having, it is a pure form of core is present. There is no clady, see the black representing the core and this white representing the clady. Okay. Without this clady I am taking. I am taking another fiber which is of black color, the same fiber. When these two fibers are clubbed to each other, just observe this, when these two are clubbing to each other, they club like this, these two fibers are clubbed to each other. When these two fibers are clubbed to each other, then what happened means light is not confined to the one fiber, it will pass into the another fiber also. Okay. I hope everybody in the class understood that. I am just drawing the diagram here to make it clear. So, please see here, I am just writing it with another fiber having the core, both are mixed to each other. The reason is they have the same refractive index. Now, just observe it, the light which is confined, in the fiber 1, see in the fiber 1 is not only present in fiber 1, it also comes to fiber 2 also. The reason is refractive index of both these two are same. At this boundary, n1 is equal to n2, light will travel to the same angle, theta 2 is equal to theta 1, moves to the same angle, light can be propagated. When that light is propagated, now the light is not confined with the fiber 1, it is mixing with each other, which creates a problem called as interference problem. Okay. It is not confined to the same one. Then similarly, what are the light present in this fiber? See, what are the light present in this fiber is also moves into the another fiber, because the light is not confined within the one fiber. This creates a very big problem, and this was proposed and also observed by a doctor instead of a scientist. Okay. How it happens I will tell to you. You know about the endoscopy, just one tube was going to be sent into the patient mouth to know about the condition of the stomach, the intestines, how they are present. Okay. Like that, the doctor was sending the tube, one tube was sending, the optical fiber tube was sent into the stomach and trying to reading or investigating some of the observations about the stomach intestine. In the meanwhile, what happened is he was not able to reach the required point because the length of the fiber is less. Then he was sent another optical fiber into the mouth. So, in the mouth now he is having two optical fibers in the intestine, and on the screen he was observing, on the doctor's screen he was observing, when the two fibers are coming close to each other, he was finding a blank on the screen. And when two fibers are going to be moving away from each other, they are separated to each other and they are not combined to each other, separate to each other, then he was going to be find out very clearly such that the image is seen internally about the stomach or about the intestines. Then he found out this and tried to make some investigation in the same patient, putting the fiber close, blank, removing it, and he started thinking why this is becoming blank when it is coming close, and he found out such that when the two fibers are coming to each other, the light is going to be not confined, the signal of this fiber is not confined within this fiber, it is passing through another fiber. That is why the overall resultant we are seeing in the screen is going to be completely blank. Then he proposed, we need not only a core for a fiber, we also need a clady to confine the light to pass within the fiber, and this is what the investigation done by the particular doctor. So, I can explain you about that part. So, please see here all of you, I am removing this core and as well as this clady. So, I hope everybody in the class will understand this one. Now, just try to understand that another important thing is I am doping some impurities. When I am doping some impurities, dekho bhaiya, impurities are doping. By doping these impurities, what happened is your core, the pure form of the core is now mixed with some of the impurities. By mixing with some of the impurities, we are going to be getting a clad. So, what is the clad? Clad is nothing but an impure form of the clad, of the core, sorry. Clad is nothing but an impure form of the core. By doping some of the impurities into your core, we will making it as a clady, and whose refractive index is equal to N2, whose refractive index is equal to N2, and that is what I want to show it to you here. So, I hope everybody in the class understood this. So, this one is the impurities. By doping some of the impurities, the clady was formed. Okay, the clady is formed by doping some of the impurities, and we can see that this is the core. See, this is the core, and we are forming some clady. So, clady is formed, and this is called as the clady we can have. So, core is N1, and we can write the clad. The clad is equal to N2 we are having. And here also we can tell about that clad is formed. Now, clad is formed on the two sides, which is providing the two important things. Please see very carefully, guys. The first important thing is it avoids the interference of the light. It can confine the light only to the core. Whatever the light is present, it is present within the core only. It is not making to interfere with the other parts. That is the first thing. Second important thing is nothing but an core will always increase the mechanical strength of the fiber. Okay, core always increases the strength of the fiber. It increases the strength of the fiber. And third important point you can find out is core avoids the contamination of impurities into the fiber. If you put a fiber in the nuclear environment, it avoids the contamination of that fiber in the core. What are the nuclear environment is affecting, that affects on the clad only, the clad avoids the contamination of impurities into the core. Therefore, your light is confined to pass within the core. So, what are the three important things? The three important things is avoids the interference, second one is increases the strength of the fiber, third one is avoids the contamination of the clad, contamination of the core. So, this is nothing but an three important points which are very very important for your fiber. So, fiber consists of two things, one is core, other one is clad. Okay. Now, just see here, guys, whenever we see about the concept explaining with a yellow color bhaiya, just try to understand this. Now, we are making the light to pass from here, it is the light source, LS. LS stands for the light source. From this light source, you are coupling the light into the fiber. So, you are passing your light into the fiber. Whenever you are passing your light into the fiber, just observe one thing. So, this is air. Air means the refractive index of air is N0, that N0 value is equal to 1. The refractive index N0 value is equal to 1 we are having. Okay, N0 value is equal to 1 we are having. So, this is equal to N0. So, your N0 value is equal to 1. Refractive index of air is approximately equal to 1. So, after writing this, you can find out clearly such that your refractive index value is equal to N0 is 1. So, N0 means the light is moving from air into core. Light is moving from air into core. That means it is moving from rarer to denser medium. Yes or no? Moving to the core of the fiber. So, rarer to denser medium it is moving. What is the denser medium? Denser medium is glass. Refractive index of core is nothing but an N1. N1 is equal to 1.5 if it is manufactured with a pure form of a glass. Okay. Now, that is what the light is moving from rarer to denser medium. We studied in yesterday's topic. So, this is the boundary. Just try to understand. This is the boundary. What are we having is called as the boundary. From the light source, a light signal was going to be incident. Dekho bhaiya, it is incident light. Okay. It is called as the incident light we are having. Line drawn perpendicular to the incident light is called as normal. This is called as the normal we are having. So, line drawn perpendicularly is said to be called as the normal we are having. It is called as the normal we are having. Which is the line drawn perpendicularly is called as the normal we have. I hope everybody in the class understood this. And whatever the light it is going to be present here will maintain an angle called as theta in. This is the amount of light it was accepting by a fiber to pass into the core of the fiber. Now, that light was passing into the core of the fiber, moving from rarer to denser medium, that is why it is moving away from close to the normal. So, this is the normal, it is moving close to the normal we are having, it is moving close to the normal is present. Now, just try to understand guys, it is moving close to the normal, straight line, it is moving close to the normal. So, to have the internal reflection, total internal reflection, Here the angle what it is maintained is called as theta c, and this angle is called as theta p. Theta p is called critical propagation angle or also called propagation angle. Theta c is called as critical angle. Critical angle we study in the yesterday's class. Now this is the incident light. This incident light will going to be take TIR, total internal reflection, and the light is passing into a fiber by having a total internal reflection like this. The light is passed into a fiber. So I hope everybody in the class understood this concept. That is how the light is passing into a fiber. It is the maximum angle at which the light is accepting by the fiber and pass through a fiber. The angle is the maximum angle theta in. Acceptance angle is the maximum angle at which the light was accepted by a fiber and passed through a fiber in it. The principle what happening here is called as TIR. TIR stands for total internal reflection we are having. I hope everybody in the class understood this. Now just try to understand the small part here. One more thing, I am just doing the calculations. So for example, this incident light, see, for example, this incident light is less than theta c, then light cannot take TIR, the light can get reflected. That is called as the ray is losted. Why it is losted? Because it is not moving into the core, it is moving away from the core and passing into clady. That is why that light is not useful for us. It is called the ray is losted. Whatever the light ray we are having, that is losted. I hope everybody in the class understood this. Now just try to understand the one more part here, one more small topic, that is doing the calculation part. I am doing the calculation part. This point is said to be called as A. This point is called as A. Now we are applying the Snell's law. So simply apply Snell's law at A. By studying about the Snell's law, see, apply Snell's law at A. Snell's law at A. I told in yesterday's class, Snell's law will give the relation between your refractive index and the angle, what the angle we are having. Now just observe clearly, N naught, the refractive index of air is N naught. N naught into sine of the angle is equal to theta in. Theta in is called acceptance angle, and that is equal to, this part is called core, that is core N1. N1 into the value is said to be called as sin theta p. Sin theta p. Theta p is called as the propagation angle we are having. So theta p is called propagation angle is present. So I hope everybody in the class understood this. So N naught into sin theta in is equal to N1 into sin theta p is the value we are having. So what is N naught? N naught value is equal to 1. Therefore sin theta in is equal to N1 into sin theta p. N1 into sin theta p. Now I request all the students, we need to find what is sin theta p. Okay, just see this triangle, the triangle maintained by this point which is shown here. This is the triangle which is maintained here. It is called as theta p. Theta p is called critical propagation angle. It is called theta c. Theta c is critical angle. Bhaiya, already we studied in the classroom, yesterday's class. What is the sin theta c we studied? Sin theta c is equal to N2 by N1. Very good. Sin means always it will give opposite by hypotenuse. By hypotenuse is nothing but an sin theta c is present. Now just try to understand one simple point here. Sin theta c is equal to N2 by N1, that is equal to opposite by hypotenuse we are having. It is called as sin theta c. So for this opposite is this one which is given as N2. Hypotenuse is this which is given as N1. And you know this angle bhaiya, this is nothing but an hypotenuse square minus N2 square, that is the side whole square. We will go into under the root of that value will gives you the value of the another side. Okay. So after doing this part, I will ask the students to tell what is sin theta p. Dear students, sin theta p for this opposite, that is under the root of N1 square minus N2 square whole divided by hypotenuse. Hypotenuse is equal to N1. I hope you understand. From this triangle, I explain you about the sin theta p. Okay. So next one is cos theta p. If you write about the cos theta p, your cos theta p is equal to adjacent by hypotenuse. Just remember the formula for cosine. So cosine is equal to adjacent by hypotenuse, that is n2 by n1. So what is theta p? Theta p is called critical propagation angle, or simply we can call it as also propagation angle. Okay, which is called as a propagation angle we are having. So this is what said to be called as sin theta p and cos theta p is present. So we got these values. So I hope everybody in the class understood up to here. So now what I am trying to doing is I can substitute the value of sin theta p in this derivation. So which will gives you the required value. So writing about the sin theta in, so sin theta in is equal to n1 into sin theta p is equal to under the root of n1 square minus n2 square whole divided by n1. So these two will get cancelled out to each other. Then we can write the value called as theta in. Theta in is equal to sin inverse of under the root of n1 square minus n2 square is nothing but an your critical acceptance angle, also called as the acceptance angle. It is called as your acceptance angle. It is called as acceptance angle. What is this one called as? It is called as critical propagation angle. It is called as the critical propagation angle we are having. So this is the critical propagation angle is present. So it is completely about your concept, which is given as the theta in acceptance angle. So please copy this part. I will explain the points regarding topics also. Please copy this one. Today's topic starts with acceptance angle. So please copy this one. Once you complete copying this part means I will tell the remaining one. I will explain the total internal reflection angle note also. You leave some space like 2 or 3 lines, or you can write the note also bhaiya. Write down the note for total internal reflection, all of you. Yesterday's class, total internal reflection note, first point. Audible? Right. Total internal reflection वाला का note. First point I am telling, total internal reflection. First point note. If angle of refraction is 90 degrees or greater, if angle of refraction is 90 degrees or greater, if angle of refraction is 90 degrees or greater, then the light ray is not allowed to penetrate. Then the light ray is not allowed to penetrate less dense medium. Not allowed to penetrate less dense medium. Not allowed to penetrate less dense medium. So total reflection takes place. So total reflection takes place at interference. So total reflection takes place at interference. At interface. Sorry. Total reflection takes place at interface. Then angle of incident theta I. Then angle of incidence theta 1, then angle of incidence theta 1 is equal to angle of reflection theta 3 is equal to angle of reflection theta 3. Angle of reflection theta 3. Write down. Theta 1 is equal to theta 3. Theta 1 is equal to theta 3. Theta 1 is equal to theta 3. Okay. So, the next one is to provide TIR, the total internal reflection, the total internal reflection to provide TIR, the total internal reflection in brackets, to provide TIR, the total internal reflection in brackets, the angle of incidence theta 1, the angle of incidence theta 1, at core and cladding must be greater than, or equal to the critical angle theta c, must be greater than or equal to the critical angle theta c, right. Next point, the basic principle of fiber optical communication is, total internal reflection. The basic principle of fiber optical communication is total internal reflection. Total internal reflection. Okay. So, please put the heading as acceptance angle. I will tell the points also. Please put the heading as acceptance angle. Okay. Write on the first point. It defines the maximum angle in which external light ray may strike the interface and still enter the core to propagate down the fiber. To propagate down the fiber. Okay. Right. Next point. Rotating the acceptance angle around the fiber core axis describes the acceptance cone of the fiber input. fiber core axis describes the acceptance cone of the fiber input. Acceptance cone of the fiber input. That second point concept I need to explain to you. Please, you can copy the acceptance angle. I will explain the cone of acceptance to you. Nana. भैया कॉपी होने के लिए प्लीज पुट ए मैसेज. I can scroll down for the remaining concept. Please copy it. So, please see here, please copy this part also, acceptance angle. Right. So, thank you for the message. I am just explaining you the another concept that is called as cone of acceptance. Cone of acceptance. So, see here, when you talk about the cone of acceptance, this is called as core of the fiber. The refractive index of core is equal to N1, and this is called as axis of the fiber. Axis of the fiber, which is called clady. N2, and this is called as the axis of the fiber we are having. At this point we are incidentting some light which is passed total internal reflection and pass into a fiber, and here also we are having an incidence of light which will pass into a fiber like this. With respect to this axis, this will maintain an angle called as theta in. This will also maintain an angle called as theta in, and this entire angle what is maintained is said to be called as 2 theta in. So, cone of acceptance is nothing but an 2 theta in we are having, which is called as 2 theta in is called as cone of acceptance. So, light was accepting with a cone, some cone, and it is passed into a fiber propagating down the fiber also, okay, which is called as cone of acceptance we have. So, next concept after completion of this, that is called as numerical aperture. It is called as numerical aperture. When you see about the numerical aperture, it is denoted as NA. Numerical aperture is denoted as NA. I will tell you the 3 points here, just try to understand. The light gathering ability of a fiber, light gathering ability of a fiber is called as numerical aperture. Light gathering ability of a fiber is called as numerical aperture. It is also called as figure of merit, FOM. FOM stands for figure of merit of optical fiber. So, the more light was gathering by a fiber, the figure of merit is very high. Always require the figure of merit to be high. Higher the figure of merit, then amount of light gathering is going to be very high. It is a figure of merit we have. And third important thing, it is called figure of merit of the fiber is called numerical aperture. The third important point that we can see here after the light gathering is, it will always tells about the magnitude of the acceptance angle. It gives you the magnitude of the acceptance angle. So, what are the points I wrote here are very important about the numerical aperture. The first point I told to you is the light gathering ability of an optical fiber. The figure of merit of FOC or OFC optical fiber cable is given by numerical aperture. Okay. So, if you talk about that, it is used to measure the magnitude of acceptance angle. So, numerical aperture is used to measure the magnitude of acceptance angle we are having. Okay. So, I can tell the formula for your numerical aperture, that is given as NA. NA is nothing but an under the root of value is equal to N1 square minus N2 square, which is called as numerical aperture we are having, under root of N1 square minus N2 square. So, after that I want to tell you the another important thing. This is the formula we have, and obviously you knows that your N1 value is greater than N2. So, because of doping some of the impurities, the refractive index will decreases. There is a decrement in the refractive index, and that is going to be the reason N1 is greater than N2 we have, and there is having a very small difference is there, very small difference, that is N1 is approximately same as N2, that is having very small difference we are having like 0.02 or 0.001 like this, very small difference is there. That is why N1 and N2 are approximately same also you can add. They are not equal, they are approximately same. It seems to be very close to each other values. Okay. So, that is what the case, so numerical aperture. What is your sin theta in? We studied in the classroom in the last topic, sin theta in is equal to this formula, that is equal to under the root of N1 square minus N2 square, the previous topic. Then what is sin theta in? Your sin theta in is equal to NA. NA stands for numerical aperture. Then theta in is equal to sin inverse of NA we are having. That is equal, theta in is equal to sin inverse of NA is present, which is called as your numerical aperture formula, which is given like this. That is called as your theta in is equal to sin inverse of NA. NA stands for the numerical aperture we are having. So, this is the formula said to be called as theta in. So, I hope everybody in the class understood this. So, please make a note of this part. After cone of acceptance you write this one. At last I will tell you points of this as a note to you. So, whatever I wrote here are the main points, this only elaborating to you. The light gathering ability of fiber is numerical aperture, figure of merit of optical fiber cable OFC. OFC is numerical aperture. The numerical aperture always measures the magnitude of the acceptance angle. So, magnitude of acceptance angle, magnitude of theta in I am writing. So, by seeing these points you get a complete clarity regarding this. In the notes I will explain complete the in detail about these points to you. Okay, please भैया, please copy it. थोड़ा जल्दी copy करो भैया, हमको न्यूमेरिकल्स भी सॉल्व करेंगे और 3 कॉन्सेप्ट्स बचा हो गया. कॉपी करने के बाद एक मैसेज डालिए भैया चैट बॉक्स में. No AR sync, they don't create any interference. The reason is they are going to be having the modes of light, different modes of light are passing through it, and that concept I explained to you. Okay, they don't create any interference because they are different modes of light, and those different modes of light will travel with different wavelengths, and therefore they won't create any interference. Okay. I am very much happy you guys, you are giving messages very frequently about after complete the copying. Thank you Keshav, thank you Aditi Sharma, thank you Pranav, thank you Dubey. Right, please write on the first point Nana as a note, write on the first point. I hope everybody completed. Write on the first point. First point, numerical aperture is used to describe. Numerical aperture is used to describe. Used to describe the light gathering ability of optical fiber. Is used to describe the light gathering ability of optical fiber. The light gathering ability of the optical fiber. The light gathering ability of the optical fiber. Of optical fiber. Next point. The figure of merit of OFC. The figure of merit of OFC. The figure of merit of OFC. OFC is given by numerical aperture. 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 Next point. NA is used to measure. NA numerical aperture is used to measure. Used to measure the magnitude of acceptance angle. Is used to measure the magnitude of acceptance angle. Used to measure the magnitude of acceptance angle. Magnitude of acceptance angle. Measure the magnitude of acceptance angle. Acceptance angle. Okay, right. Next topic. Next topic is a relative refractive index difference. Relative refractive index difference. Relative refractive index difference, which is said to be called as delta. Which is said to be called as delta. When you see about the relative refractive index difference, it is denoted as delta. The name itself indicates refractive index difference, but relatively we need to speak. Do you observe that most of the light is passing through the core? That's why we need to speak relatively with respect to the core. See, the formula I am giving to you, delta by a derivation is not required for us. Delta is equal to n1 square minus n2 square. See the relative refractive index difference. See refractive index difference. It is refractive index difference here. N1 square minus n2 square is the difference. That is the relative refractive difference. Relatively we need to speak. That is equal to 2n1 square. I am relatively speaking with respect to the core. We can with respect to the clad also, means divided by 2 n2 square also we can write, but we are talking with respect to the core. Why? Most of the light is passing into the core. Okay, by taking TIR, total internal reflection, most of the light is passing into the core. Okay, now please see here, this is the formula. Now I can explain you about the simplified formula, that is called as simplified of this formula we are studying in the classroom. Right, by देखो भैया delta is equal to, do you observe this a square minus b square? A square minus b square can also written as a minus b into a plus b, that is n1 plus n2. So whole divided by, the value is given as 2n1 square. Already I told you in the classroom, your n1 is approximately same as n2, but they don't become equal, so this is not become 0 भैया. Don't make this 0, some difference is there. Okay, so then understand clearly delta is equal to n1 minus n2 into n1 plus n2 is equal to 2n1 whole divided by 2n1 square we are having. This will get and get cancelled out to each other. Delta is equal to n1 minus n2 divided by n1 we are having. This is the delta value we can have, which is said to be called as relative refractive index difference. See, refractive index difference I am taking, relatively speaking with respect to which one? It is with respect to the core. We can write the same formula like this also, delta is equal to n1 minus n2. What is that? Refractive index difference. See, refractive index difference, this is the refractive index difference relatively. Relatively I am speaking with respect to the clad. This is with respect to the clad bhaiya, this is with respect to the core, and both remains the same. With respect to clad we can take, with respect to the clad core also we can take. Okay, now this is the formula, but here small thing, that is they are not exactly same, they are approximately same. The reason is simplified version, they are approximately same we are having. Okay, why n1 is approximately equal to n2, that is why this approximation, simplified form we are having. This is about relative refractive index difference. So please copy it bhaiya. Once copying is complete, please put a message. Right, see here. So I hope everybody in the class complete this topic bhaiya. If anybody likes writing the last equations, please write it. This is with respect to, what is this? Core. With respect to, what is this? Clad. Very good Nana. So next one is, I am talking about the next topic, that is called as relation between NA, numerical aperture, and delta. Numerical aperture and delta. Now just see here carefully, all of you. Study about the formula. What is NA? You study in the formula under the root of n1 square minus n2 square. Bhaiya, what is delta formula you study in the classroom? n1 square minus n2 square divided by 2n1 square. I hope everybody in the class understood this. Bhaiya, see here from this equation, I am writing like this, Na square is equal to, see squaring on both sides, Na square is equal to n1 square minus n2 square. Okay, ठीक है. Now भैया देखो भैया, delta is equal to n1 square minus n2 square is equal to Na whole square. देखो भैया, होल डिवाइडेड बाई 2n1 स्क्वायर क्या हो जाएंगे, ये 2n1 स्क्वायर में रिलेशन आ जाएंगे, डेल्टा का Na स्क्वायर के रिलेशन है, ये पहला रिलेशन है. We can like this also from this one. देखो भैया, Na square is equal to, the value is written as like this, that is equal to 2n1 square into delta. I hope everybody in the class understood this. I am taking the denominator to the another side, that is equal to 2n1 square into delta. Then क्या हो जाएंगे, Na भैया, Na को दोनों तरफ स्क्वायर रूट करेंगे. सो दोनों तरफ स्क्वायर रूट करने के लिए what happened to the value is n1 into root of 2 into delta, and this is the formula. This is the delta and that is the Na. What is the relation we are having? So I give the two relations to you. I hope everybody in the class understood this. This is what the relation you can find out between numerical aperture and delta. So please copy that part, Nana. All of you please copy that one. Copy that part. Copy that part. I'll explain the next one. Right. So I already received the messages from some of the students. Copying is completed. Explaining the next concept. So please see here, light propagation. Light propagation in fibers. Light propagation in fibers. So when we discuss about the light propagation in fibers, there are three ways of light propagating in fiber. The first rays are called as meridional rays. These are called as meridional rays. The second rays are called as axial rays. They are called as axial rays. And the third one is called as skew rays. They are called as skew rays. So I need to explain you about all these three things. What is meridional rays, what is axial rays, and what is skew rays. Meridional rays are the rays which are passed to the axis and also cross the axis. Axial rays are the rays which will pass along the axis. Okay, along the axis, they never cross the axis, they pass along the axis. Skew rays are the rays which does not pass through the axis. These rays pass to the axis and cross the axis. These rays only pass along the axis. Skew rays never pass along the axis. Clear bhaiya? Never pass along the axis. So dekho bhaiya, I will explain with a neat diagram. I will tell the points to you in the notes very clearly to you. So don't worry much about that. So whatever the complete review of optics you study in the classroom is for your meridional rays and for the axial rays. Right. Remaining concepts of will also satisfy for the skew rays also, but there are some changes with the acceptance angle with the skew rays and acceptance angle of the meridional rays. That is very important. That is what the topic we will see in the skew rays. So I hope everybody complete copying. So this I will explain to you meridional rays. Meridional rays are the rays which are going to be passing through the axis, along the axis, and also cross the axis or pass through the axis. So first of all I am explaining the meridional rays diagram bhaiya, just concentrate. Meridional rays. rays. So देखो भैया, this is core. Try to understand core of the fiber. So see here, when you talking about the axial rays, that is meridional rays are the rays I explained to you already. Those meridional rays are going to be passing through the fiber axis, and as well as it is also crossing the axis of the fiber. See, crossing the axis of the fiber and passing along the axis of the fiber, or the ray can also pass like this also. But if you see here axial rays, the axial rays are the rays which are going to be passing. See, this is the core of the fiber, and we can take about this part which is called clady of the fiber. Clady of the fiber, it is called as N1 and it is called as N2 we are having. So this is the axis of the fiber. Do you observe clearly? This is called as axis of the fiber we are having. So once we talk about the axis of the fiber, we understand very clearly such that the light ray has to be passed only through the axis of the fiber. It never crosses the axis. See, observe it. This is passing through the axis and also crosses the axis. What is this doing? Passing through the axis. Please find the difference by passing through the axis, and cross the axis also, but here it is only passing through axis, it never crosses the axis. Those are called as axial rays. Passing through the axis we are having, it is passing through the axis. Now we can tell about that it is passing through the axis. So passing through the axis, it only passes through the axis. So after this we can talk about the next one, that is called as skew rays. So dekho bhaiya, talking about the skew rays, I hope you understand this topic. So discussing about the skew rays, it is called as the skew rays we are having. So when you talk about the skew rays, so skew rays are the rays which does not passes through the axis, okay, which does not passes through the axis. Which does not passes through the axis is called as skew rays. Through the axis is called as the skew rays. So, students can observe this part clearly. So, after completing of this part, I will explain you the remaining things. So, I will tell you some of the points. I will write the main points here, which are very important for us. So, first point I wrote there, which does not passes through the axis. Your skew rays will always takes a path called as helical path. They take a helical path. And if you talk about the skew rays, these are difficult to trace. These are difficult to trace. Whenever you send a light by using the skew rays, it is difficult to trace. Okay, so becomes somewhat difficult for us to trace these light. And the third important thing is the acceptance angle of the skew rays is always greater than the acceptance angle of the meridional rays. Acceptance angle was studied by us in the classroom as a notation called as theta in for the meridional ray, and theta in S stands for the skew rays by Your S stands for the skew rays. Therefore, theta in S is for the skew rays meridional rays we are having. So, once we talk about the skew rays meridional ray, that is skew rays meridional rays we are taking. So, what we observed here clearly is the acceptance angle is very high. Acceptance angle is very high means amount of light that is going to be passing into a fiber with very wider angles also accept more light and pass into a fiber. That means more amount of light is coupled by the skew rays when compared to the meridional rays or to the axial rays. So, this is the one of the beautiful advantage of the skew rays, but we can't use this in communication systems. The reason is because of the difficult to trace, they are difficult to trace. So, out of all the three, we are mostly using the meridional ray, and the second one is axial ray. Okay, skew rays are conceptually we will study the skew rays, but applications part we are having very less amount of applications are present. And we have gamma, the gamma is called as the reflection. If you draw a diagram, you get a clarity regarding that, what is that gamma and what is the reflection we are having. So, देखो भैया इधर हमारा फाइबर है, सो फाइबर का कोर एंड फाइबर का क्लैडी है. सो देखो भैया ए फाइबर का कोर है, ए फाइबर का कोर, सो फाइबर कोर इज प्रेजेंट लाइक दिस. Refractive index of your core is equal to N1 and this is called clady. So, clady refractive index is equal to N2. So, this value is equal to N2 we are having. The refractive index of core is equal to N1 and the refractive index of clady is equal to N2 we are having, and this is what we said to be called as your skew rays are present. So, once we talk about the skew rays, we can tell like this. So, this is the axis of the fiber is present. So, please follow the yellow color line. I will show it to you how the light is passing. See, light was coupled into a fiber. So, light is coupled into a fiber. It hits here, take reflection, and again it hits like this, take reflection, hits like this by taking reflection and passing through it. See, there is not going to passing along the fiber. See, assume that I make a clarity, this is the fiber core that moves like this helical path, moves like a helical path. By it moves like this helical path by getting reflection and moving like this. It doesn't pass through the axis of the fiber, does not passing through the fiber. Okay, so which is said to be called as the skew rays we have, and this is the path which will takes by the skew rays, and this is the path which will takes by the skew rays. Here I am showing you the your side front view of the fiber, that is core, and this is called as clady, and this is the front view which is shown in the figure. So, having a front view is present. So, this value is called as 2 gamma. Gamma is called as the reflection, total reflection we are having, which is called as the reflection is present, and only single one means it is called gamma, and gamma plus gamma is called as 2 gamma we are having. It is completely about the skew rays we are having. So, this is about the skew rays, this gamma is present. So, I will explain you another important thing, that is called as theta in S. I am giving the formula. Just see here, that is given as, what is the formula for theta in we study in the classroom? Theta in formula we study in the classroom is sine inverse of under the root of n1 square minus n2 square. Okay, that is the formula for theta in. See, for theta in, that is the formula. Now, theta in S in the sense means sin inverse of root of n1 square minus n2 square divided by the value is equal to cos gamma. The value is equal to cos gamma is present. If your gamma value is equal to 0, there is no reflection. Dekho bhaiya, if you see the meridional rays, in the meridional rays we don't have any reflection, there is no reflection bhaiya. So, it is passing total internal reflection taking and light is passing through it. But when you talk about the skew rays, you are having some reflection and that reflection is given by the gamma and the gamma value is present. If gamma is 0, cos 0 is equal to 1. When cos 0 is equal to 1, your theta in S is equal to theta in we are having. So, whenever gamma is equal to 0, your acceptance angle of skew rays and acceptance angle of meridional rays both becomes same. But what the condition I told to you is the acceptance angle theta in of skew rays is very greater than when compared to that of the meridional rays. So, this is the concept which will lies behind the skew rays. We do not use this in communication purpose because of difficult to trace, and for that reason we always go for the meridional rays. But one of the advantage is the light can be accepted from very wider angles, amount of light pass into a fiber is also very high. Okay. So, this is equal to that of your concept called as skew rays. Bhaiya, you can write down the point, I will explain the points to you as a note. Okay, please copy it. If you see here, this is the meridional rays. For meridional rays, the light was passing through the axis and also crosses the axis. Passing along the axis and also crosses the axis is called meridional rays. But axial rays are the rays which will pass along the axis. They will pass along the axis only. They never crosses the axis. See, it is not crossing bhaiya. It is passing along the axis of the fiber. Okay, or passing through the axis of the fiber. Okay, skew rays means they never pass through the axis of the fiber. They take a helical path, they are difficult to trace. We do not use it in communication system. We always use the meridional rays or the axial rays will be used. I hope everybody in the class understood this, right? So, please copy this part, Nana. I will give some time for to copy this part. Later on I will explain I will show you the slide of skew rays. Okay. Please copy this. Once it is done, please put a message in the chat box. As you seeing, I explain the meridional rays to you once again. Hope it is clear for you. Please copy this one. Skew rays also copy this part. Yeah, AR Singh, I show it two rays in the meridional rays. See, the one ray what I showed here is passing through the crossing the axis and passing along the fiber. Second ray I show it to you is the ray can also pass along the axis also, along the axis straightly also. They are two rays, it is not single ray, they are two rays. Okay, right. Right on the first point, skew rays. Skew rays are not confined to a single plane. I am explaining the note. First point, students please write down the first point. Skew rays are not confined to a single plane, but tend to follow, T-E-N-D, but tend to follow a helical type path, along the fiber. Next point. These rays are more difficult to track. As they travel along the fiber. Next point. The helical path traced through the fiber. Gives a change in direction of 2 gamma at each reflection. Next point. The skew rays provides more acceptance angle. Than the meridional rays. Next point. Skew rays are complementary to meridional rays. And increase light gathering capacity of fiber. and increase light gathering capacity of fiber. Light gathering capacity of fiber. Okay. Last point. For most communication design purpose, for most communication design purpose, meridional rays, design purpose, meridional rays are considered, design purpose, meridional rays are considered. Okay. So, this is completely about your review of optics topic. So, we will solve some numericals. So, based on this review of optics, please all of you put the side heading as examples or numericals. Okay. So, head on the first question. Determine the optical power in dBm, for power level of 10 milliwatts, for power level of 10 milliwatts. Okay, right. See here, Bhaiya, first question Bhaiya, numericals we are solving. I request all the students talking about the power in dBm. So, what is the power P given Bhaiya? Power P given is equal to 10 milliwatts is the power given. So, 10 milliwatts is given. So, asking to find out what is the power in terms of dBm. What is the power in terms of dBm? It is a normal power level converting into dBm. Bhaiya, we study in the classroom power present in the dBm with a formula. The reference is with respect to 1 milliwatt. That means 10 into log of power P divided by 1 into 10 to the power of minus 3, which is equal to dBm is present. So, base 10. Now, this value is equal to, please substitute that value, given value of P 10 milliwatts is given. So, 10 to the power of minus 3. So, 1 into 10 to the power of minus 3, the value is equal to dBm. So, these two will get cancelled out to each other. So, log 10 of base 10 is equal to 1. So, the answer is equal to 10 dBm we are having. So, please all of you see here one small part, I will explain to you here clearly for you. Note, Bhaiya dekho, whenever your power P is equal to 1 milliwatt, when the power P is equal to 1 milliwatt, if it is equal to 1 milliwatt of power we are having, I put here P is equal to 1 milliwatt Bhaiya, so everything cancel out, log of 1 is equal to 0. So, 0 dBm means do not think the power is equal to 0, power is equal to 1 milliwatt. Generally, if power P is equal to 1 watt, you will get 0 dB. But when power P is equal to 1 milliwatt, that is equal to 0 dBm we are having. So, observe carefully another point, if power P is greater than 1 milliwatt, you always get positive dBm. See the same example Nana. What the power we are having is 10 milliwatt. The power P is equal to 10 milliwatt Bhaiya, then automatically what the dBm getting is positive dBm. Whenever the power P is less than 1 milliwatt, we will get negative dBm. So, you will get the negative dBm is present. So, obviously, we got a negative dBm. So, why I am explaining this small table to you is, in most of the cases, they will tell that 0 dBm power is present, is fiber launching 0 dBm power. The means such that is, we are giving power P is equal to 1 milliwatt of power we are launching into a fiber. And for this question, I am not giving any options. If I give you options, you can tell the answer very easily also. The reason is, it is 10 millivolt. So, They give out of 4 options, 2 options negative, one option is 0 dBm, another option is positive as 10 dBm they can give. So, power P is greater than 10 milliwatts, greater than 1 milliwatt, therefore, it is called as positive. So, positive dBm is the answer. So, one technique, without doing anything also we can tell the answer in the engineering service exam. Okay. So, please copy it by all of you. So, first question. Sagar, sure, I can dictate slowly. AR Singh, 10 dBm is the correct answer. Complete copying. Next question. Next question. Please write down the next question. Let medium 1 be the glass. Let medium 1 be the glass and medium 2 be the ethyl alcohol. Question number 2. Let medium 1 be the glass and medium 2 be the ethyl alcohol. Full stop. For an angle of incidence of 30 degrees, calculate the angle of refraction. For an angle of incidence of 30 degrees, calculate the angle of refraction. Angle of refraction. Option A 25 degrees. Option B 28 degrees. 28.2 degrees. 28.2 degrees. Option C 30 degrees. Option C 30 degrees. Option 4 33.4 degrees. Option 4, that is option D 33.4 degrees. Option A 25 degrees. Option B 28.2 degrees. Option C 30 degrees and option D is 33.4 degrees. Okay, right. Please solve the question. That is question number 2. That is question number 2 we are having. Yeah, what is the medium 1 is given? Medium 1 is glass. The refractive index of glass N1 is 1.5. What is medium 2? Medium 2 is ethyl alcohol. It is ethyl alcohol. N2 is equal to 1.36. By angle of incidence is given theta 1 is equal to 30 degrees is given. Theta 1 is equal to 30 degrees is given. So, already we study in the classroom asking to find out what is theta 2. Theta 1 is angle of incidence, theta 2 is angle of refraction. To find your angle of refraction, we use a law called as, which one? Snell's law. Yes or no? Then we get like this, N1 into sin theta 1, N2 into sin theta 2. देखो भैया N1 का वैल्यू हमको मालूम है 1.5, साइन ऑफ 30 डिग्रीज, थीटा 1 भी मालूम है, क्वेश्चन में दिया. N2 is equal to 1.36, value is equal to sin theta 2. So, theta 2 is equal to 33.4 degrees is the answer we are having. I will explain a shortcut, because we cannot solve this without the calculator. We need a calculator for this one, because sin inverse is there. Inverse operations we can't remember all those values. But how can you solve this without calculator? It's very simple, Nana. Just see here, carefully observe here. Bhaiya, N1 is greater than N2. Shortcut I am explaining. N1 is greater than N2 means your N1 refractive index is glass, and glass is higher when compared to the ethyl alcohol. When N1 is greater than N2, definitely theta 2 is greater than theta 1. We study in the classroom. Theta 2 is equal to theta 1 we are having. Okay. So, this is what we studied, that theta 2 is greater than theta 1. So, that is what is the theta 2 we are having, that must be definitely greater than 30 degrees. See in all the options, option A 25 degrees, not an answer. Option B 28.2 degrees, not an answer. Option C 30 degrees, not an answer. Option D 33.4 degrees is present. Which is your answer? That is very simple. So, without having calculator also, without substituting the Snell's law also, by seeing this condition, you can tell the answer directly for your ESE exam. Because in ESE prelims they do not allow you for the calculator. So, such that we are completely use this type of techniques to solve the questions. Okay. वाह, इतना response किया. All the answers. Komal correct answer, AR Singh correct answer, Suraj correct answer, Pandey correct answer, Shubhra Pandey correct answer, Radhika Devi correct answer. Okay. Right. I think copying is also completed. So, please write on the next question, Bhaiya. So, write on the next question. A certain optical fiber has refractive index of core N1 is equal to 1.40. A certain optical fiber has refractive index of core N1 is equal to 1.40. and that of clad N2 is equal to, and that of clad N2 is equal to 1.05, clad N2 is equal to 1.05, full stop. Its numerical aperture will be, its numerical aperture will be, its numerical aperture will be, okay, I am not giving the answers, you can please solve the question. Na value, Na is required, question number 3, given that N1 is equal to, how much is the value of N1 is given, N1 is equal to 1.4, 1.40, N2 is equal to 1.05. Asking to find out what is the numerical aperture, Na is equal to how much. Observe carefully, Na is given as formula under the root of N1 square minus N2 square, under the root of 1.4 whole square minus 1.05 whole square. We can approximate 1.05 as 1 square, this is 1.4 square, means approximately 14 square. So, 14 square minus that 1, out of that the value will be obtained. So, use your calculator to get the value, and that is equal to 0.926. The answer is equal to 0.926 is the numerical aperture value. So, this is called as Na, numerical aperture value. Like some approximation we can do it and we can get the value. That is your question number 3. I will explain next question, that is question number 4. I hope everybody got the answer. Komal, correct answer. Shubhra Pandey, correct answer. A.R. Singh, correct answer. Aditi Sharma, correct answer. Radhika Devi, correct answer. Somya, correct answer. Right, good response. Please copy down the next question. It is a gate question, previous gate question. In gate also we can have the subject optical communication, which is part of your EMTL subject. Applications of your EMTL, you can study this how light is propagating into a fiber, review of optics, types of fibers also is there, which is very much important. So, in the gate there are some previous years questions also available for the subject. I will explain some questions out of them. Please write on the first question. The refractive index of glass is 1.5. The refractive index of glass is 1.5. 1.5. Full stop. Find the wavelength of a beam of light. Find the wavelength of a beam of light with frequency of 10 to the power of 14 hertz, with the frequency of 10 to the power of 14 hertz in glass, with the frequency of 10 to the power of 14 hertz in glass, 10 to the power of 14 hertz in glass, full stop. Assume velocity of light is 3 into 10 to the power of 8 assume velocity of light is 3 into 10 to the power of 8, 3 into 10 to the power of 8 meters per second, 3 into 10 to the power of 8 meters per second, 3 into 10 to the power of 8 meters per second in vacuum. In vacuum. I request all the students please solve the question. Please try this one. It's a gate question, previous year gate question. Right. See here, given that N1 is equal to 1.5 and velocity of light is given C 3 into 10 to the power of 8 meters per second and frequency f is equal to 10 to the power of 14 hertz is given. Asking to find out what is the wavelength. Bhaiya, he wanted the wavelength of the light which is passing into the core of the fiber. Just see here, refractive index formula study in the classroom. N is equal to C by V. So, V is equal to C by N, that C is given 3 into 10 to the power of 8 meters per second in vacuum, whole divided by N. Refractive index of glass, N is equal to 1.5. Then we will get a 2 into 10 to the power of 8 meters per second will be obtained. That is the V. Already I told you such that wavelength of the light that passing into the glass. So, lambda is equal to V by F. I hope you understand this formula. We study in the classroom, yesterday's class. Lambda naught is equal to C by F naught and lambda is equal to V by F. Yesterday's class we studied when you are talking about the refractive index formula. Now, we will tell about the value of V. Velocity of light V is equal to 2 into 10 to the power of 8 meters per second whole divided by F, frequency. 10 to the power of 14 hertz, hertz is written as 1 by second, this will get cancelled out and you are getting 2 into 10 to the power of minus 6 meters, also given as 2 micrometers is the answer we are having. So, what is the operating wavelength? The light passing into the fiber, the light having a wavelength of 2 micrometers is passing into the fiber. AR Singh correct answer, Suraj Patel correct answer, Komal Mohite correct answer. So, they are correct answers. So, what is the general simple mistake what we will do is, we will take like this, lambda is equal to C by F and we write 3 into 10 to the power of 8 meters per second divided by 10 to the power of 14. Then you get some lambda is equal to 8 minus 14 something approximately some 300 nanometers will come. Okay. Lambda like this, but this is not a correct answer bhaiya, it is a wrong answer. The reason is, you do not want a free space wavelength, with that frequency, we want what is the wavelength that is passing of light into a free space, that is what is how much of light is passing into the wavelength of light passing into the glass fiber is required. Okay. So, refractive index of glass is given. Yeah, correct answers. Soumya, please cross check, it is not 4.5 micrometers, it is 2 micrometers. Yeah. Please write on the next question. This is also gate question. Light from free space, light from free space, light from free space is incident at an angle, light from free space is incident at an angle theta I, at an angle theta I to the normal of a step index fiber, to the normal of a step index fiber, to the normal of a step index fiber shown in the figure, to the normal of a step index fiber shown in the figure, step index fiber shown in the figure, full stop. The core and cladding refractive index, the core and cladding refractive index, the core and cladding refractive index are N1 is equal to 1.5, or N1 is equal to 1.5 and N2 is equal to 1.4 respectively, and N2 is equal to 1.4 respectively, full stop. The maximum value of theta I in degrees, the maximum value of theta I in degrees, theta I in degrees, for which the incident light, for which the incident light will be guided, for which the incident light will be guided in the core of the fiber is, for which the incident light will be guided in the core of the fiber is, will be guided in the core of the fiber is, in the core of the fiber is. Okay. So, if you see here, question number 5. This is the diagram given. All of you please observe this diagram. In the question itself it is given, shown in the figure. So, this is N1 refractive index, this is N2 refractive index, this is the axis of the fiber, and this is the normal we are having, and for this normal it is written very clearly, it is a normal we have. So, this angle what it is maintained with the normal is called as theta I. Theta I is nothing but an, which is said to be called as, very clearly it is given as angle of acceptance or acceptance angle. So, what the refractive index is given? N1. N1 value is equal to 1.5 it is given, and N2 value is equal to 1.4. We can feel free to use our calculators bhaiya, there is no restriction because it is a gate question. Okay. So, what is theta I? We study in the classroom bhaiya. Theta I is equal to what is the formula? Sine inverse of under the root of N1 square minus N2 square. These questions are come from the electromagnetic theory, EMTL. This part of optical communication is present with the EMTL, okay, for GATE and as well as ESE students. So, theta I, if you talk about the theta I is equal to sine inverse of under the root of N1 square. N1 square is equal to 1.5 whole square minus 1.4 whole square is the value we are having. and that theta I, please use the calculators, feel free to use the calculators bhaiya. Already some students has given the answer 32.58. Komal, correct answer 32.58 degrees, which is the correct answer we are having. So, asking to find which angle na, theta I is called as acceptance angle. With that angle the light is accepting to pass into the fiber. It is the angle, acceptance angle we are having. It is called theta I. Theta I is equal to 32.58 is present. You are seeing correct answer. Suraj Patel, correct answer. Pandey, correct answer. What is the next question? It's mains question. Next question. In a step index fiber, the relative refractive index difference, is 2%, and the refractive index of Clady is 1.4. Clady is 1.4. Find the first question. Refractive index of core. Find the first question. Refractive index of core. Second question. Critical propagation angle. Next question, numerical aperture. Question number 3, numerical aperture. Question number 4, acceptance angle. Question number 4, acceptance angle. Please use your calculators, no problem. It's a mains question. Calculator is allowed in the mains. Okay. If the same question is asked in the prelims, please leave the question and go for the next question, because without calculator we can't do anything. Okay, please. Question number 6. First of all, I read the given data. Question number 6, given that. So, what are the data was given? Your delta is equal to 2%, meaning is 2 divided by 100 equal to 0.02. We are having. So, that is called as the delta is given. And he gives the value of N2 is equal to 1.4, value is equal to 1.4, which is N2 value. And what he was asking to find out is, he was asking to find out N1 is equal to how much, theta P is equal to how much, NA is equal to how much, theta N is equal to how much. They are the values. So, I can explain first of all with your delta by taking delta is equal to N1 square minus N2 square divided by 2N1 square. So, we know the delta value is equal to 0.02, we need to calculate N1, but we know N2 is equal to 1.4 is equal to 2N1 square. Now, just observe here, that is equal to 0.04 N1 square is equal to N1 square minus 1.4 whole square. If you talk about this value, you will get the value of your N1, and such N1 value 0.04 N1 square is equal to N1 square minus 1.4 of whole square, and such N1 value is equal to, so using the calculators we get the value is equal to 1.42. Okay. I will tell one shortcut how to calculate your N1 directly without doing all these things is, already N2 is given, that is equal to 1.44, that is equal to 1.4, and you know your delta is equal to 0.2. By adding these two, you will get our N1 value, and you add these two, that is 1.42 is the value of N1. So, like this we can take, because there is a relative index difference, relative refractive index difference, get the N1 value directly like this, N1 is equal to 1.42, it is a shortcut. So, next one I need to explain here, that is called as your second question, that is theta P. Bhaiya, we study in the classroom theta P. Theta P is equal to cos inverse of N2 by N1, that is equal to cos inverse of N2 by N1. N2 का वैल्यू क्या है, 1.4 है, N1 का वैल्यू 1.42 है. Then your theta P you will get some value, use the calculator and tell the value. भैया न्यूमेरिकल अपेक्चर का फॉर्मूला क्या है, अंडर द रूट ऑफ N1 स्क्वायर माइनस N2 स्क्वायर है. So, numerical aperture NA is equal to under the root of 1.42 whole square minus 1.4 whole square. इसी के लिए हमको एक वैल्यू आता, use the calculator and tell that value ना. Next one is called as theta in. Theta in is equal to that of sin inverse of numerical aperture, that is equal to that of sin inverse of numerical aperture है. numerical aperture का वैल्यू चाहिए, इसी के लिए हमको भी theta in का वैल्यू आ गया. ओके So, this is 11.46 degrees we are getting, 0.2839 and 16.49 degrees is getting. Okay. So, these values, correct values, that is 11.46 degrees, 0.283 we are getting. 0.283, that is equal to 0.283 something, you will get like 36 or 16.49 degrees we are getting, 16.49 degrees. 16.49 degrees we are getting. Okay. Please put the calculators in degrees. cos inverse of n2 by n1, how much you are getting? Just type cos inverse of 1.4 divided by 1.42 theta p. I think we are getting 11.46 only. Please cross check, Nana, all of you. Please copy the next question. I think we are getting 0.28 only, Komal. Please cross check it once again. The values using the calculators. So, write on the next question. Calculate the refractive index of core and claddie. Calculate the refractive index of core and claddie of fiber. Calculate the refractive index of core and claddie of fiber if it has numerical aperture. If it has numerical aperture 0.22, numerical aperture 0.22 and delta is equal to 0.012. Numerical aperture 0.22 and delta is equal to 0.012. And delta is equal to 0.012. And delta is equal to 0.012. Yeah, please solve this question. Use free to use the calculators, put it in degrees and solve it, asking n1 and n2 to find out. Okay, bhaiya, all of you cross check your answers. Question number 7. Question number 7 it is. Question number 7. So, given that numerical aperture is given, Na is equal to 0.22, it is equal to 0.22 and delta is also given, the value is equal to 0.012, value of delta is equal to 0.012 we are having, which is numerical aperture Na is equal to 0.22, delta is equal to 0.012 is present. Asking to find out what is the value of n1 by a and what is the value of n2 also. Asking to find n1 and n2, refractive index of core and refractive index of claddie. Right भैया, right. Solve करो. So relation क्या है? Na is equal to n1 into root of 2 delta है. We get n1 is equal to Na divided by root of 2 delta. What is Na? Already given in the question भैया. 0.22 whole divided by root of 2 into delta 0.012. Already study about this relation. You will get some n1 value. Then we need to find your n2. Numerical aperture whole square is equal to n1 square minus n2 square. Then n2 square is equal to n1 whole square minus numerical aperture whole square. So what is n1? I need to find that. I am expecting the answer from your side for n1. So that is equal to 0.22 whole square is the value we are having. So your n1 value is equal to 1.42 we are getting. So, n1 value is equal to 1.42 and that value is equal to 1.42 whole square, and that will gives your n2 value is equal to, so under the whole root of 1.42 whole square minus 0.22 whole square. So, your n2 value is equal to, Bhaiya, can you please tell me what is the value of your n2 we are getting? So, approximately some 0.012 will be added, then that value is equal to 1.4029, 1.402 we can write now, 1.402 is the value we are having. So, this is completely what we said to be called as your n1 and n2 values. I will explain the next question, question number 8, that is the last question, and we will take a break for 15 minutes for our dinner or supper. Anjunaik, we cannot take our value of delta is equal to n1 minus n2. It is required for us to write the values n1 minus n2 divided by n2 or n1 is required. Yes, AR Singh we can use simplified form also, you get the maximum same answer only, there is no change in that. Okay.
ए और बी में यही रहेगा ब्रेक के पास ये.
What is the next question? An optical fiber in air. Next question, an optical fiber in air. An optical fiber in air has numerical aperture of 0.4. Has numerical aperture of 0.4. 0.4. We'll stop. Compare the acceptance angle. Compare the acceptance angle for meridional rays. For meridional rays with that of skew rays. Which is that of skew rays. Which is that of skew rays. Which change in direction by 100 degrees, which change in direction by 100 degrees with each reflection, which change in direction by 100 degrees with each reflection, okay. See here Bhaiya, question number 8, change in direction by with each reflection, change in direction by with each reflection. Yeah, please see here all of you. So, question number 8, talking about the 8th question, given that Na is equal to 0.4, 2 gamma is given 100 degrees. See, each reflection means 2 gamma. Okay, half the reflection means it is equal to gamma. Then what is gamma? Gamma is equal to 50 degrees. Now skew rays and meridional rays. First I am writing for meridional rays. Bhaiya, can you please tell me for meridional rays what is theta in? Theta n is equal to sin inverse of under the root of n1 square minus n2 square also written like this, sine inverse of numerical aperture is called theta in. Theta in is equal to sine inverse of numerical aperture, that is equal to sine inverse of NA, NA is equal to 0.4. So, using the calculator you get the value. Now, I am discussing about the meridional rays. देखो भैया, talking about the skew rays, completed the discussion about the meridional rays, now started with skew rays. Please tell the formula for theta in S. Theta in S is equal to sine inverse of under the root of n1 square minus n2 square divided by cos gamma. Also written like this, sine inverse of numerical aperture upon cos gamma, that is equal to theta in S. देखो भैया, theta in S is equal to sine inverse, numerical aperture का वैल्यू 0.4 है, cos gamma का वैल्यू को cos ऑफ 50 डिग्री से, गामा का 50 डिग्री से, इन दोनों को सॉल्व करने के लिए हम थीटा इन एस का वैल्यू आ गया. सो व्हाट इज आस्किंग इज चेंज इन एक्सेप्टेंस एंगल. सो चेंज इन थीटा इन. सो चेंज इन थीटा इन इज इक्वल टू थीटा इन डेल्टा, दैट इज कॉल्ड एज चेंज, और डेल्टा थीटा इन आल्सो वी कैन राइट. डेल्टा थीटा इन is called as the change we are having. So delta theta in is called as the change, that is given like this, which is given as theta in S minus theta in. So we want the values of theta in. Yeah, we have to want the values of theta in. So what is the value we are having for your theta in is 23.57, okay, 23.57 degrees, and what is the theta in S we are having is, theta in S we are having is 38.48, that is equal to 38.48 we are having, 38.48 degrees is the value we are having. So, the difference we are having is 38.48 minus 23.57 degrees, approximately 15 degrees of difference we are having by acceptance angle, change in theta in. That is the difference, that much amount of difference we are having. Okay. There are some doubts that asked by the students are, if you see here carefully, in your mains exam, if you want to calculate your delta value, please use this formula. Delta is n1 square minus n2 square divided by 2n1 square. In the prelims, we use shortcut delta is equal to n1 minus n2 by n1, or your delta is equal to, that is delta n1 is equal to, or delta plus, I will make it the formula here clearly. So, or delta, that is equal to n1 is equal to delta plus n2 formula can be also be used. Okay, asking to find out, because we get the approximate answer, close to the answer we will get it, and that can be given as the answer to us, because there is no calculator for the prelims, right. So, we will see some numericals guys. When you are going for the remaining concepts, we can find out. We are solving by using this concept of solving. Already explained one question by solving like this. So, please remember this part when we are talking about the optical communication for mains and prelims. Mains there is no issue because you have a calculator, but the major thing is with the prelims only. The calculator is not allowed, but we have to have a questions which are solved with respect to the numericals. We need to solve it. So, that is why we can face a little bit problem. So, most of the times if you are very bit fast with squaring terms and square root, sine inverse is becoming difficult for us. Okay. So, take a break of your 15 to 20 minutes break. So, we will see after the break. Okay. Please copy this question.